Okay, this is our last video for Unit 5. We're going to be doing solving polynomial functions of higher degree. I know there seems to be a lot of writing here, but really it's not that much. So if you just take your time and get everything copied, pause the video, and then come back to me and we'll go over all the details. Alright, so to solve polynomial functions of higher degree, we need to learn how to do it algebraically and graphically. We're not going to do graphically today on the video. We're going to do that in class tomorrow. But since you have the steps written, that'll be good because it'll save us some time. Let's take a look at the algebraic steps. It says you need to factor, set the factors equal to 0, and solve for the variable. If factoring is not possible, use a quadratic formula. So basically it's saying try to factor in t-bar, and if you can't do that, then you've got to use the quadratic formula. And really, that's nothing new for us. The only thing new is that because it's a higher degree, we're not going to be dealing with x squares. We're going to be dealing with x cubes, x to the 4th power, x to the 5th power. So going down here to where all the little stars are, right over here, it says you should expect to find the same number of roots as the highest exponent. So for example, x cubed means that we should have 3 roots since the highest exponent is 3. And sometimes the roots will come out to be doubled, and that's okay. So you're going to have to notice that sometimes the roots do repeat. All right, with that being said, let's go on to our first example. Solve the following algebraically and graphically. Again, we're going to save this graphic part here for tomorrow. Okay, so we're going to just deal with it algebraically. All right, first of all, it's in standard form. It's set equal to 0, so we're going to see if we can factor in t-bar. I can't GCF. Let's see if I can go to 2 binomials. Let's see, what will give me x to the 4th? X squared times x squared, which is good because that's what I need in the middle. Factors of a positive 64, that'll give me a negative 20. Negative 16 and a negative 4. All right, let's take a look at those binomials again. Oh! X squared minus 16 is dots. I can factor him to be x plus 4 times x minus 4. And x squared minus 4 is also dots, so I can factor him to be x plus 2 times x minus 2. I can't factor anymore, so now I'm going to t-bar. I'm going to end up with x is a negative 4. Whoops, that's a bad negative 4. Sorry about that, guys. X is a positive 4, x is a negative 2, and x is a positive 2. Now I have 1, 2, 3, 4 answers, or what they say is 4 roots. And if I take a look at the highest exponent, it is a 4, so I am supposed to have 4 roots. So my answer can be written in a set notation as plus or minus 2 and plus or minus 4. Or again, you can just write it out as 2, negative 2, positive 4, negative 4, however you want to do it. All right, so we definitely need to make sure we have all the answers by checking out how many roots we're supposed to have by looking at the highest exponent. With that being said, let's go on to another example. Solve each of the following just algebraically. Okay, we can do that. Find the zeros of the function p of x equals x to the 5th minus 12x cubed plus 32x. All right, looking at it, is it in standard form? Well, p of x stands for y, and then if I'm not graphing it, I can set it equal to 0. So I'm going to write it as x to the 5th minus 12x cubed plus 32x equals 0. Looking at the highest exponent, I should end up with 5 roots, or 5 answers. If I don't, then I may have done something wrong. All right, first things first. It looks like I can GCF out an x, so I'll get x to the 4th minus 12x squared plus 32 equals 0. All right, looks like I probably could go to 2 binomials, bring down that x because it's part of my answer. Set up my 2 binomials. It's going to be an x squared and an x squared. I need factors of a positive 32, that'll give me 12. Minus 8, that'll give me a negative 12. So it's a minus 8 and a minus 4. All right, I can't do anything more with the x. I can't do anything more with the x squared minus 8. But x squared minus 4 is dots, so it's going to be x plus 2 times x minus 2. The only thing I have left to do is t-bar, but right now I'm getting a little nervous, and hopefully you're getting nervous with me because I'm only seeing 4 roots. Well, let's see how this goes. I'll do all the ones that are easy. X equals 0, so there's a root. X equals a -2, there's a root. And x equals a +2. X squared minus 8 is a little bit harder to solve, so let's write it as x squared minus 8 equals 0. I'll add 8 to both sides, so I have x squared equals 8. I'll square root both sides, so I'll end up with x equals, simplify radical 8 to 2 radical 2. Ooh, but it's going to be plus or minus 2 radical 2. Oh, that gives me 2 roots, so I'll have 1, 2, 3, 4, 5 roots, just like I said. So my answers are going to be 0, plus or minus 2, and plus or minus 2 radical 2. Hopefully you realize, and I'll show you off to the side here, that the square root of 8 is really 4 times 2, which is 2 radical 2. That's where I got that from. Okay, so we found all the roots for number 2, and we found 5 of them because the highest exponent was 5. It's called a degree 5 polynomial. Let's take a look at our last example here, number 3. Solve the equation. Don't worry about that 13 of 13. That's just a page number that got copied by accident. All right, so let's see. It looks like they factored it for me already because I already have a binomial times a trinomial. So first I have to concentrate and think, if they didn't take them apart like that, what would have been my highest exponent? Well, it would have been an x squared times an x squared, which is an x to the 4th. You're right. So I should end up with 4 roots here. All right. At this point, I think I'm going to t-bar. No, I'm not going to t-bar. I'm going to see if I can factor any more. Are there any factors of a +1 that'll give me a +4? Nope, so I can't do anything more with that guy. So I got to bring it down as x squared plus 4x plus 1. But x squared minus 9 is dot, so I have x plus 3 times x minus 3. All right, I can't go any further with this, so I'm going to t-bar at this point. And again, I'm starting to get nervous. I have an x equals a -3 and an x equals a +3. If I set this one equal to 0, x squared plus 4x plus 1 equals 0, I can't solve it as easy as I did the one in number 2 because I have a squaring. I don't have factors of a +1 that'll give me a +4 when added, so I'm going to have to do the quadratic formula to that part of the t-bar. All right, so let's see what we've got here. We have our value of a is going to be a 1, b is going to be a 4, c is going to be a 1. We have x equals a negative of b plus or minus the square root of b squared minus 4 times a times c over 2a. Okay, let's see what we got now. X equals a negative of 4 plus or minus the square root of 4 squared minus 4 times 1 all over 2 times 1. Okay, x equals a negative 4 plus or minus the square root of, put that in my calculator, I got 12 all over 2, which would be negative 4 plus or minus, I would use 4 times 3, which would be 2 radical 3 over 2. So I can simplify by 2. X is going to equal negative 2 plus or minus radical 3. And that'll give me 2 roots, because really it's negative 2 plus radical 3 and it's negative 2 minus radical 3. So I got all 4 of my roots. So my answers are plus or minus 3 and negative 2 plus or minus radical 3. So we found all our answers to question number 3. Take a look at this over again before you actually close it out for the evening and make sure that you have a total understanding. If you don't, please bring your questions to class tomorrow. See you then.